Okay, welcome back. And in the previous video, I had you convert from grams to molecules. Okay, in this case, we're going to convert molecules back to grams, but the sequence is just backwards, right? So if you are starting with grams, then you use the molar mass, right? And then you do a mole equals 6.022 10 to the 23 molecules. And then you don't go that extra route, okay, to get atoms, right? Here, so this is our molecule destination, right? Okay, this is our starting point, this is our molecule. But that's what we did in the previous problem. But in here, we're going to go back. So molecule, this was your first step, first checkpoint, and then this is your second checkpoint, and then finally you're going to end up in grams. But the rule of thumb stays the same. You always start with the given information. So you're given molecules and you're asked to find grams. So this is what you're asked to find, and this is what you're given, right? So write 3.2 e to the negative e to the 25 molecules. It's not negative, it's just e hyphen. I'm going to probably not even use it in the remainder of the videos because you might think it's negative. It's just hyphen of molecules of Al2SO4 3, right? That's pretty long, but you got to write all the information possible. And as always, put 1 on the bottom because, again, there's nothing to go with, right? What's the reverse? When we go reverse, we have molecules at the top, right? So the conversion of molecule must go on the bottom and the mole must go on the top. Well, this is the first step in the reverse direction. So the 1 mole should go at the top and the 6.022 e to the 23 molecules go on the bottom, right? That's your second step. So this is our first checkpoint, and then the second checkpoint would be, well, we got our moles, right? Now we can cancel out the molecules, but we still have moles left. What do we want? Ultimately, we want grams is our answer. So we cannot have this mole, and we have to go get the molar mass of Al2SO43, right? So this is a good practice. So you have 2 aluminums, right? There's 3 sulfurs, right? 3, and then there's 4 oxygens, but it's a 3. Now, do you see why I had you put the brackets when we learned the polyatomic ions in homework 3? If not, it's going to be appearing it as 43 oxygen, and that means we will never be able to account for sulfur and also incorrect quantity of oxygens. So, but we have a total of 12 oxygens. Okay. So I didn't do a separate problem for this. I realized if you want, I can make a separate video just for calculating the molar mass, but this knowledge is all you really need. So if I go to the periodic table and I look at the atomic mass of aluminum, it's almost 27. I just rounded it off because, you know, it makes my life easy. It's like 26.98. I just rounded it off to the nearest whole number, so it's 2. So it's 54. And each sulfur is 32, so it's 32 times 3. That'll be 696. And then there's 12 oxygens. It's not 120. Okay, it's 12 oxygens. So it's 12. Oxygen is 16 times 12 is 192. Okay, these are the individual atomic masses of elements in this given compound. So now you add them all up, so it'll be 192 plus 96 plus 54, that's 342. That's the total atomic or molar mass, so that is 342 grams over 1 mole, right? So here we have moles at the top. If you see me write MOLE and you write me MOL, they're the same thing. Sometimes I forget to write the E sometimes, because they're both correct ways of writing it. So if you don't see me write E sometimes write E. Again, I can keep track of it, and neither of them are incorrect. So I don't think it's a big deal, right? So 1 mole, so the mole goes on the top and the 342 grams goes on the top. Okay, now we can get a different color. Let's see, we can get our red. So we can now cancel out the mole and the mole. That leaves us with just the unit we want, which is grams. Now we can just go get our calculator and do the math. So it's 3.2 exponent 25 divided by 6.022, 23, and then you multiply that by 342. So that's going to be a massive number. So it's going to be 18,173 grams. Okay, to really have that many molecules, you have to have had this many grams. Okay, that's what it comes down to. Don't worry about the number; it's too big. Again, this is a completely made-up number, and so based on the numbers I've given you, that number seems to make sense, and that's how you do your gram from molecules to grams conversion. Okay. If you want, I can do another problem. Okay. And again, this is not a negative. It's an hyphen. Some conventions used to write the hyphen. Maybe for the remainder of the videos, like I said, I will try not to write the negative. If it is negative, I will tell you that it is a negative. Okay. All right. So that is it. So if it's a negative, here's how I would write it. So let's actually do a different problem. Okay, let's actually take this, okay, and repeat it, but this time, okay, if I actually show it as negative, here's how I'm going to show it. Okay, so how many grams, okay, are there in, if I say, I mean, negative or positive, okay, are there in, say, 8.3 e to the negative 25. Okay, now that is a negative. Okay, I'm not going to solve this problem, but here's how I would say it's negative. Okay, 8.3 e to this is not a negative. Okay, that's just convention of not negative. Okay, if it is just written that way, some people just don't want to put the 25 right next to the e, so they put a hyphen. So, but when you do have negative, it's written as an exponent, as like in top. All right, so this is a negative exponent. Okay, and this is not a negative exponent, not negative exponent. I just want to make that difference so that you don't ever think that I'm referring to a negative. If it is negative, it's written at the top. If it's positive, it can be written next to each other or with nothing on it. Okay, if it's e to the 25, that just means it's a positive exponent. But negative, you have to be more careful. So I just wanted to point that out, so that that little hyphen you saw was not negative. That's just an hyphen, right? All right, so if you were to solve this for, say, calcium carbonate, okay, how many grams are there in 8.3 molecules of, go back, say this is the question, so molecules of calcium carbonate, right? Right. So you write your given information. Again, the sequence is grams, and you go to molar mass, and then you go to your 1 mole equals 6.022 e to the 23 molecules. And these are the conversion steps, and that'll lead you to just molecules, right? So that means we start with the given information as always. So it's 8.3 e to the negative 25 molecules, right, of calcium carbonate. That's the given information. As always, your first column on the far left-hand side, the bottom column is 1 because there's no information to furnish. And let's go get a different color. Now we're backtracking, right? We're going backwards from molecules to grams, right? So first step is, this is the given information. That's this starting point right here. And this is the first checkpoint, which is we got to get rid of the molecule. So we put the 6.022 e to the 23 molecules, and then the 1 mole at the top, because we got to keep in mind we got to get rid of this, right? Right. So the second thing is, let's go get a different color again. Okay. Now we're finished with checkpoint 1. That's checkpoint 1. Checkpoint 2 is you have to get the molar mass, and I believe I've already done this. Calcium, I believe the atomic mass or molar mass is 40. So calcium is 40. Carbon is 12. Again, I'm rounding it off. You can do the same, or you can use the actual values that's appearing in the periodic table. 3 oxygen is 48. So 48 plus 12 is 60, plus 40 is 100 grams over a mole. That's the atomic mass. So that's the molar mass. So it's 100 grams over 1 mole, but we don't want the mole. We want grams. So the 1 mole goes at the bottom. The 100 grams goes at the top. Now, if you notice, we want the unit, which is in grams, right? It's all about getting the right unit at the end. So 8.3 exponent negative 25 divided by 6.022 exponent 23, sorry. And that times 100. So I don't think it's realistic. I don't think anybody in the world would be able to measure this using any balance. I don't think there's a balance that's out there to the negative 46 grams, okay? Again, these are just not concept problems. It does not mean it has to translate into a real world. I don't think there is a machine that's out there that can actually measure e to the negative 46. If you're measuring, anything past milligram is very, very difficult. And this is not even milligram. This is way, way below. I don't think there is a machine out there that can actually measure. Say you have a solid calcium carbonate, you cannot even measure this. This is impossible, okay? But again, some of these problems, while they have a practical application, again, the problem I picked, this is the number we get, and so this is an unrealistic number. We cannot ever actually work with this number, but the concept is correct. Okay? That's what's important, right? The concept is correct, the content is correct. So the number, not so much. Okay. Anyway, so that's that, and then I will come back with another video on a completely new set of material. All right. So stay tuned.